Now let's review the kinematics lesson. We started out with some vocabulary. So we have here distance and then displacement. Distance is the total path traveled, and displacement is how far you have gone from start. Very often they are the same thing. If you start here and you're traveling in a straight line to the end, your distance and displacement would be the same thing. Okay? We also had two other words we looked at, and speed, velocity, and we looked at the differences between those. They are both the rate at which you are changing your distance. So speed is distance over time. Velocity is displacement over time. Okay? And the only really other difference in velocity is it has a direction. So it has a direction in which you are traveling. Velocity, displacement over time, direction in which you're traveling. Acceleration was our final word that we used, and acceleration is how fast you are changing your speed or velocity. And we get change in velocity, delta means change in, all over time. Just to review a little bit about the graphing and what it can tell from motion, distance time graph, the slope gives you speed or velocity. The slope of any distance time graph gives you speed or velocity. The velocity time graph, the slope of any velocity time graph gives you acceleration. So it's a visual representation of what you are doing. We also looked at the words scalar versus vector. Scalar quantities are quantities with a magnitude only, a numerical value, a number. So speed, distance, those just have numerical values. Other things like mass would just have a numerical value, time, no direction at all. Vector quantities have a direction associated with it. Acceleration has a vector quantity because it has a direction. Velocity, vector quantity. Displacement, vector quantity. And we'll use this as we go along our lessons in physics. Now, our final review of kinematics had the equations. And we started with our very simple one. Average velocity is total distance over time, or total displacement over time. Then we went into our acceleration equations. So you don't use this equation if you're accelerating. You need to use an acceleration equation. And our first one we looked at was VF equals VI plus AT. Final velocity equals initial velocity plus acceleration times time. And our second one, distance or displacement, is VIT plus 1/2 AT squared. Nice about this one is oftentimes we're starting from rest and this cancels out. And lastly, we used VF squared equals VI squared plus 2AD. And one other thing to note, whenever we're in free fall, meaning where objects are falling freely or we're throwing things up, we know the acceleration due to gravity is a constant negative 9.8 meters per second squared. The negative sign simply means the direction for acceleration due to gravity is always downward. If we throw an object up, it's slowing down because of gravity, which is going down. And that is our review.